This is AP Calculus 5.3, determining the intervals on which a function is increasing and decreasing. To begin this, we're going to review a little bit of Algebra 2 and pre-calculus that we've done previously, and then we're going to relate that information to how we deal with the same information in calculus. If you look at this function, we know it's a cubic function because it's got two curves. So we know that the highest degree of this is a third degree, third power. We know that the relative maximum is at this value right here, and the relative minimum is at this value here. They are not considered global maximums because this goes down forever in this direction and up forever in this direction. So these are just your relative or local maximums and minimums. We know, based on previous knowledge, that a function is increasing as x moves from left to right if the function is going in an upward direction. And that maximum will change, or the minimum will change the direction of the function. So this function is increasing until it gets to the maximum, and then it begins to decrease as we move from left to right until we get to the minimum, and then it begins to increase again as we get past that minimum. And we know that the point of the maximum or minimum is the point where direction changes. Now, how are we going to relate this to calculus? Well, if you think about what you know about calculus, we know that when a function is increasing, the slope of the tangent line is a positive. It's going in a positive direction. When the function is decreasing, the slope of the tangent line is going in a negative direction. And when the function is increasing again, the slope of the tangent line is in a positive direction. So if we're given an equation for a function like this, all we have to do to be able to determine where the function is increasing and decreasing is find our critical values. Remember, critical values are where the derivative has a horizontal tangent line or where the derivative is undefined. So anywhere you have a maximum or a minimum, those will be critical values for the function that you've been given. Anywhere you have an asymptote or a hole in the graph, or anywhere that you have a sharp curve or a sharp turn would be considered critical values. Something special is happening there. So if we can set up intervals between the maximum or the critical values and plug those values, or plug a value from that interval into the first derivative, then we'll be able to determine whether a function is increasing or decreasing, because if f prime is positive, that means the function is increasing. If f prime is negative, that means the function is decreasing. So basically what we're going to be able to do is we're going to find our critical values, we're going to set up a table dealing with those critical values, and then we're going to set up intervals. The intervals for this graph, the x value for the maximum is going to be a cutoff point, and the x value for the minimum will be a cutoff point. So for this function, we would have three separate intervals. One that goes from negative infinity to whatever the maximum x value is. One that goes from where the maximum x value is to the minimum x value, and then another from the minimum x value to positive infinity. And then we're going to plug some x value in within that interval into the f prime function and determine whether that f prime is positive or negative. If we plug a value that's to the left of this x value into the derivative, then it's going to come out as a positive slope. If we plug a value between these two x values into the f prime function, then it's going to come out as a negative. If we plug in a number, an x value to the right of the minimum here, then it's going to come out as a positive. Anywhere the function has a derivative that is positive, it's increasing. Anywhere the function has a derivative that is negative, the function is decreasing within that interval. And we don't necessarily have to have a graph to be able to do that. We can do that algebraically just using our knowledge that we have in calculus. So if your directions tell you to find all open intervals where a function is increasing or decreasing, the first thing you're going to do is you're going to find the critical values. So to find the critical values, I'm going to find the derivative of the given function. So f prime of x for this one would be 3x squared minus 3x. And then to find the critical values, I set that derivative equal to 0. If I set that equal to 0, I can factor. I'm going to bring out a 3x, so I have an x minus 1 left over, and then I set each factor equal to 0. So 3x equals 0 gives me x equals 0 as a critical value, and x minus 1 equals 0 gives me x equals 1 as a critical value. So the two critical values that I have for this function are at x equals 0 and x equals 1. The next thing I need to do is I'm going to set up a table that uses these x values as our cutoff points. So now, this function goes from negative infinity to infinity. So if my cutoff points are at 0 and at 1, I know something special is happening at 0, something special is happening at 1. So I'm going to set up my intervals. I'm going to set the first one up from negative infinity to 0. So my first interval goes from negative infinity. X is between negative infinity and 0. That's an open interval. The next open interval goes from 0 to 1, so x is between 0 and 1. 1, x is between 1 and infinity would be our third interval. These are open intervals. I make the cutoff points at 0 and at 1 because we already know those are our critical values. What we're trying to determine is what's happening within the intervals between those values. So here, what I'm going to do is I'm going to choose a number between that interval, and a real simple number to choose would be negative 1. I'm going to choose something between this interval, I'll just say 1/2, and I'm going to choose something between this interval, I'll just say 2. I'm going to keep it simple. And then what I need to do is I need to plug these values in to f prime. So I'm going to plug those into the f prime function. Now, all I'm interested in here is whether they are positive or negative. I don't need to know their exact values, just whether they're positive or negative. Because if it's a positive f prime value, I know it's increasing within that interval. If it's a negative f prime value, I know it's decreasing within that interval. So that's all I need to know, whether they're increasing or decreasing. That's what the directions have asked me to do. We'll do more with that in the next section, but for now, all we need is whether it's increasing or decreasing. So if I plug negative 1, a number between or within that interval, into my f prime function, I'm going to plug it right here because it's real easy to determine if it's positive or negative based on my factored form. So if I plug negative 1 in, this will be a negative. If I plug negative 1 here, that will be a negative. So a negative times a negative gives me a positive. That's all I need. If I plug 1/2 in, 3 times 1/2 is positive. 1/2 minus 1 is negative. So a positive times a negative is a negative. If I plug 2 in, 3 times 2 is positive. 2 minus 1 is positive. Positive times positive is a positive. So what this means is, within the interval from negative infinity to 0, my f prime function is positive, so that means my function is increasing from negative infinity to 0. From 0 to 1, my f prime was negative, so that means my function is decreasing from 0 to 1, and my f prime was positive between 1 and infinity, so that means my function is increasing in that interval. The next thing they're going to want you to do is to justify your answer. So if I'm looking for a justification for how I know where this function is increasing or decreasing, what I can say is this. I can say f of x is increasing on the open intervals negative infinity to 0 and 1 to infinity, because f prime is greater than 0 within those intervals. I can then justify that f of x is decreasing on the open interval. Now, I could just say on the interval, because if I use parentheses, I know they're open intervals. So on the interval 0 to 1, because f prime is less than 0 within that interval. So there's my justification with my work to finish off that problem. I've answered the question they asked. Where is this function increasing or decreasing? I also want to make sure I do at least one example with a trig function. This one says find all open intervals where f of x equals 1/2 x minus sine x is increasing and decreasing on the interval 0 to 2 pi. When you're dealing with trig functions, they will have to give you an interval to consider, because as you know, trig functions are run as a cycle. So they continue and they repeat over and over again. So with that, understanding that, if your trig function is telling you, or if the interval they give you is going from 0 to 2 pi, that means they want you to go one revolution around the unit circle to get your answers. Otherwise, we would have an infinite number of answers, and we would have to justify those answers some way using like an n value to show where this critical value or the increasing and decreasing functions happen within the entire trig function, and that becomes pretty tedious as we do that. So they will almost always give you an interval to deal with when you're working with trig functions. So the first thing I'm going to do to decide whether a function is increasing or decreasing is I'm going to find the derivative, because we know when the derivative is positive, it's increasing. When the derivative is negative, it's decreasing. So f prime of x for this function would be 1/2 minus the derivative of sine is cosine x, and the derivative of x is just 1, so that's not going to change anything. We don't need to multiply by anything in front of the cosine, because 1's not going to change the value. Next, I find the critical values. To find the critical values, I will set that function equal to 0. So if I think about this, 1/2 is equal to cosine x. So I need to find all of the values between 0 and 2 pi where cosine of x equals 1/2. So I need to consider my unit circle. We know cosine is the x value of my ordered pairs around the unit circle. So 1/2 square root of 3 over 2 right here, that would be at 60 degrees or at pi over 3. Cosine is at 1/2. So x will equal pi over 3. And then the other x value where your cosine is 1/2 would be at 300 degrees. And 300 degrees is 5 pi over 3 in radian measure. So our two critical values for this function are at pi over 3 and at 5 pi over 3. The next thing I need to do is set up my intervals. So knowing that the intervals that we're talking about go from 0 to 2 pi, my first interval in my table is going to go from 0 to pi over 3. So x is between 0 and pi over 3. My second interval goes from pi over 3, where x is between pi over 3 and 5 pi over 3. And then my last interval goes from 5 pi over 3, which is 300 degrees. X is between 5 pi over 3 and the 2 pi to finish out that one revolution around the unit circle. I'm going to choose a value within each of these intervals. So a number between 0 and pi over 3, I think a good value to use there would be pi over 4, which is 45 degrees. We're going to choose values that we can find easily on the unit circle. Something between pi over 3 and 5 pi over 3, I'll just say pi. That's a good simple value to plug in. And then for a number between 5 pi over 3 and 2 pi, I'm going to use 330 degrees, which is 11 pi over 6. And I could, again, use a 45 degree angle if I wanted to, but I'm just going to mix it up a little bit so we have something a little different to do. Now I need to plug these numbers into the f prime function. Remember, the f prime function is right here. So if I plug pi over 4 into this function, I would have 1/2 minus, at pi over 4, the cosine is square root of 2 over 2. So 1/2 minus square root of 2 over 2. That would be 1 minus square root of 2 over 2. So we need to determine, is the top positive or negative? Well, square root of 2 is 1.414, and it keeps going. So 1 minus 1.414 is a negative. So all we need is to know that that's a negative number. When we plug pi into the function, we would have 1/2 minus cosine of pi. Well, cosine at pi, that ordered pair is -1, 0. So cosine at pi would be -1. So we have 1/2 minus -1, which would be a positive. And then at 11 pi over 6, the x value would be square root of 3 over 2. Y value would be -1/2. So square root of 3 over 2 would be my cosine of x there. So 1/2, if we do 1/2 minus square root of 3 over 2, again, that's going to be a negative number because 1 minus square root of 3 is 1.7 something. So that's going to be another negative. So we know that this function is decreasing on the interval 0 to pi over 3. We know the function is increasing on the interval from pi over 3 to 5 pi over 3. And we know the function is again decreasing on the interval from 5 pi over 3 to 2 pi. And then for our justification, I would say f of x is decreasing on the intervals, or on the open intervals, 0 to pi over 3 and 5 pi over 3 to 2 pi, because f prime of x is less than 0 within those intervals. And I would say the function is increasing on the interval from pi over 3 to 5 pi over 3 because f prime of x is greater than 0 within that interval. Another thing they're going to ask you to do within this section is they're going to give you the graph of an f prime function and ask you to determine where the interval of f is increasing and decreasing. So what they're giving you is they're giving you the graph of f prime. They're giving you the graph of the derivative, but then they want you to answer questions based on the f function. And so basically all we really need to know here is where this thing crosses the x-axis. If we know where the function crosses the x-axis, then wouldn't those be the values where f prime has a horizontal tangent line or a critical value? So if we're looking at this, we can see here that since they've given us that this is the graph of f prime, we can see that that graph of f prime crosses the x-axis here at -1, x equals -1. It crosses the x-axis here again at x equals 1. So if you think about what this is telling you, if to the left of x equals -1, your f prime is below the x-axis, then it had to be decreasing from, in this case, -3 to -1. If the graph of f prime is above the x-axis, between -1 and 1, that tells me that f prime is greater than 0, or above the x-axis from -1 to 1. And then again, it crosses the x-axis at 1, and all of this function is below the x-axis from 1 to 4. So that tells me that f prime is less than 0 from 1 to 4. So if it's asking you where f is increasing or decreasing, really all you have to look at is where is f prime above and below the x-axis. Anywhere f prime is below the x-axis, it's decreasing. Anywhere f prime is above the x-axis, it's increasing. So if we want to justify this, we can say the function f is increasing anywhere f prime is above the x-axis. So we see that f prime is above the x-axis on the open interval from -1 to 1. If we want to state where f is decreasing, then all we have to do is look where f prime is below the x-axis. Here we can say f is decreasing from -3 to 1. And from 1 to 4. Those are open intervals, so I used parentheses to signify those. If I want to further my justification there, I could say f is increasing on the open interval from -1 to 1 because f prime is greater than 0 within that interval. Here I could say f is decreasing on the open interval -3 to 1 and 1 to 4 because f prime is less than 0 within those intervals. That would be a fine justification for this graph that we have here.